Hey guys, this is the homework help video of chapter 6, and we're going to first be doing review question number 1 on page 83, which says, in the interaction between a hammer and the nail it hits, is a force exerted on the nail, on the hammer? How many forces occur in this interaction? So let me just see if I can draw this. Sorry, my hand is a little injured. It might be a little shaky. Yeah, my hand is cut up, so it might be a little shaky. But let's just try this. Okay, that's a decent hammer. Okay, so hammer here, and we have the nail here. Okay, and so when the hammer comes down and it strikes the nail, let's give that a force. Let's call that 50 newtons, and let's also identify that as an action force. Action force. And we can title this A. This force is A, or the hammer is A, and we can title the nail B. And interestingly enough, you guys probably know from this chapter now that the question says, is a force exerted on the nail? Well, that's really simple. Okay, so 50 newtons on the nail, hammer's coming down. Yes, a force is exerted on the nail. But then it says on the hammer, and we identified this hammer as an action force, but we know that because of Newton's third law, there has to be a reaction force. And that reaction force is the nail exerting a force on the hammer, and it is equal and opposite to it. So it's 50 newtons in the opposite direction here, right? Opposite direction. So that's really cool. So now you can say and we actually title this reaction force, right? Reaction force. So how many forces occur in this interaction? So there's two forces. Two forces, and they are the action and reaction forces. So that's a cool question. And we just kind of also answered number 2, which says, when a hammer exerts a force on a nail, how does the amount of force compare with that of the nail on the hammer? And they're equal and opposite. So now I'm going to do number 3 really quick, and then we're going to jump to the Think and Explains, but I do like number 3. Because number 3, if you read the cartoon about the horse cart problem, then you'll get number 3 really easily. When you walk along the floor, what pushes you along? Well, that's really easy, actually. If you have the floor here, and you have some guy walking, right? Let's go, I don't know how to draw someone walking. I guess that's a decent walking person. And so, every time he takes a step, he's exerting a force on the floor. But the floor is exerting an equal and opposite force on his foot, which is actually what's pushing him forward. So the floor pushes him forward. And that's just like the horse cart problem. Now let's move over to the Think and Explains, which is page 84. And we're going to do number 19, which is the first one. And let's see, it says, your weight is the result of the gravitational force of Earth on your body. What is the corresponding reaction force? Well, let's draw us. Let's draw a person here. And here's Earth. Let's just draw Earth. Okay, here's Earth. Alright, that's like supposed to be the Earth, okay? And just to put it in perspective. And let's say this guy weighs 100 newtons. His body's pushing down on the Earth with 100 newtons of force. But this is so interesting. That's an action force. Action force. This is just fascinating. The Earth pushes up on him with 100 newtons. This is due to gravity. This action force over here is due to gravity. And this is due to Newton's third law. It has to push up. It has to have a reaction force. Reaction. That's another good one. I like number 22 a lot. Let me just clear you can go ahead and start reading 22 while I set this up. Okay, so 22 says, If you walk on a log that is floating in the water, the log moves backwards. Why? So let's just get a little diagram going here. Okay. Okay, there's your log. And let's say, just draw this. So if this person takes a step this way, then interestingly enough, so he's gonna exert a force on the log, then the log also has to exert a force on him going that way. So since the log is in this water, the fluid that things so the log will be more susceptible to move in fluid than on a solid because there's less friction. So um, he will actually the log will actually move backwards because as he exerts a force kind of downward, um, it's actually pushing the log backwards because the log is exerting a force like this, upward, which is pushing itself backwards in theory. So, um, let's see. I think that's about it. I don't want to give too many of the answers away for you because these are your homework questions, and you can use these videos as a reference. But it'd be great to do the rest of the homework problems yourself. So I will see you guys in chapter 7, which is momentum.